Saxon's Trig, Lesson 86, is about arithmetic progressions and arithmetic means. Before we get into the progressions and the means, let's talk about some of the bolded words here in the lesson. Sequence comes from the Latin word sequoi, which means to follow. If a group of numbers is arranged in a definite order so that one number follows another number, we say that the numbers have been arranged sequentially and that the numbers form a sequence. And this doesn't mean just random numbers. It means numbers in an established pattern, such as adding 2 each time. So we might have 2, 4, 6, 8, and so on. That would make a sequence. All right, then they talk about finite and infinite sequences. Finite, if you recognize that term, means has a definite number of. So this one goes from 2 to 8. That would be a finite sequence. But if I added some dots to indicate that that pattern should continue, 10, 12, 14, 16, and so on and so on and so on, then it's an infinite sequence because it's continuing on forever. And the dots would indicate that. On page 513, they talk about the English word progression that comes from the Latin word progredi, which means to go forward. So an arithmetic progression is an arithmetic sequence where the pattern is adding something each time. Now, before I continue that further, I skipped something here, which T sub 1, T sub 2, T sub 3. When I have little numbers at the bottom, that is another huge clue that you're dealing with a progression or a sequence, because that's how mathematicians have chosen to do it. So it could be A sub 1, A sub 2, A sub 3, and so on and so on and so on. And we can also see that, going back to this pattern, if they give me something like 2 blank blank 8 10 and they say fill in the blanks, that's also an indication that I'm dealing with a arithmetic progression or sequence. All right, so I've given you the term common difference, which is the fact that in this case the common difference is adding 2 each and every time. And they're using this to connect to the formula for arithmetic progression. So let me just do that here. Let's label this one A sub 1 as in the pattern. And then this one would be A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, if we were labeling them. So in order to establish the pattern, in this particular case, it's fairly easy to guess that it's a plus 2. So rather than go through the formula of finding them when they're a little harder, let's just go with the fact that we know it's plus 2. So this one, in the formula, it's remaining A sub 1. Let me go ahead and fill in our 4 and our 6 since we've labeled these. All right, so to get to A sub 2, you took the original A sub 1, which was 2, and you added to it the common difference one time. 2 plus 2 is the 4. Okay, what about A sub 3? Well, it's A sub 1, which is the 2 plus, and then how many times am I using the common difference? 2 times, because 2 times 2 is 4, plus the 2 makes the 6 for A sub 3. Let's just make sure you're understanding the pattern. A sub 1 would be, and then how many times am I adding the difference? 1, 2, 3 times. So 3D, that would be 6, plus 2 is the 8 for A sub 4. So you see how it's working mathematically. So here is the actual formula. It's A sub 1 plus, and then how many differences to get to whatever. That's the other part to the pattern you need. So if you're looking for A sub 5, then it's A sub 1 plus 4 D's. So the formula is actually saying you do the number that you're talking about minus 1 times the amount of differences, and that's the formula for an arithmetic progression. And they finally give that to you just a little below halfway down page 513. It's right above example 1. So now that you know what the formula is, and we've proven to ourselves how we find it, let's look at, no, I'm going to pause and do something else first. In the series 2, 4, 6, 8, if I did not instinctively know what the pattern was, I could find what the common difference is by doing the second number minus the first number, or the third number minus the second number. As long as they're sitting side by side in an arithmetic progression and you minus them, you are finding the common difference. The only other problem is sometimes the common difference is not just a single number. It's like a formula, and we'll get back to that. All right, example 1. Write the first 4 terms of an arithmetic sequence whose first term, so a sub 1, is 14, and whose common difference is 10. And they just want the first 4 filled in. So that's easy enough to do. I don't even really need the formula. The first one is 14. Every time I'm supposed to add a 10. So, oh, I'm so sorry. That's negative 14 as it was given. This is negative 14. Okay, negative 14 plus 10, negative 4. Negative 4 plus 10, 6. 6 plus 10, 16. So the first numbers are negative 14, negative 4, 6, and 16. I technically should probably box the commas, but you get the idea there. Example 2. Find the 25th term of an arithmetic sequence, so a sub 25. Now that I certainly do not want to list out 25 numbers to find it, even if it's as simple as add 1 to the pattern. I just don't want to take the time to do that. So we are definitely going to use our formula, which is the a sub 1 plus, and then this would be 25 minus 1 times the common difference. Okay, so whose first term is 12, so we're still finding a sub 25. First term is 12 plus 25 minus 1 is 24 times the difference. And let's see, whose common difference is negative 6. So all that information was provided in the question. So now we're just working this out. 24 times negative 6 plus the 12 should give us a sub 25 is negative 132. Now another double check, because my original one, or because my difference is negative. If this is an odd number, my answer should be coming out with a negative more than likely. If it's even, it will probably come out positive, but not guaranteed. All right, example 3. Insert 3. Oh, here's the new one. Insert 3 arithmetic means between 2 and negative 4. So an arithmetic mean, typically it means an average, but in this case, when I attach the word arithmetic to it, it means I want that many blanks in between the two given numbers. So since it called for 3 arithmetic means, I'm filling in 3 blanks here. So then I can label this one is a sub 1, and this one is a sub 1, 2, 3, 4, 5. And to establish what the difference is, I can throw this one in to the formula. So a sub 5, which is negative 4, comes from a sub 1, which is 2, plus, and then this was 5 minus 1, giving me 4 differences, and now I can solve for the D. Negative 4 equals, oh wait, I should move that 2 over first. Negative 6 equals 4D, divide by 4, and reduce, that's negative 3 halves. All right, so now that we've established the difference, we can fill in our blanks. So 2 plus, now this one, I could leave it in fraction, but I'm going to go ahead and say that it's the same as negative 1.5, because that's a whole lot easier for me to add in my head. 2 plus negative 1.5 only leaves me with a half. A half minus 1.5 more leaves me with negative 1. And then negative 1 minus 1.5 more should be negative 2.5. Negative 2.5. And just to double check, I haven't made any errors. I do the negative 2.5 with another negative 1.5. So that's 3, 4, negative 4. That's what I needed it to get to. All right, example 4. Write the first 5 terms of an arithmetic sequence in which a sub 17 is negative 40, and a sub 28 is negative 73. And that's all the information they give me. Ultimately, I'm supposed to fill in what the first 5 things are. All right, so I can take these and turn them into their formulas and solve then for a sub 1 and the d. So this one will be negative 40 equals a sub 1, which I don't know, plus, and since that was 17, minus 1 is 16 differences. Same thing here, negative 73, don't know the a sub 1, and it comes from 28 minus 1, 27 differences. And then I can eliminate the a sub 1s and solve for the d by subtracting this entire equation. Okay. Or you can change all the signs, or yeah, that's probably the best two I would do. So just be careful here as you subtract this. Negative 40 minus a negative turns this into positive 73. So it's negative 40 plus 73. So 33, that was positive, it was bigger. Then a sub 1 minus a sub 1 cancels them off. 16d minus 27d is going to turn that into a negative, no, can't be 10, 9? Hang on. 19, 27, 8, 9, 10, no, 11d. Triple checking. 6, 7, 26, yes, okay. Yes. All right, now divide. So the difference is negative 3 because I'm dividing by negative 11. Now we know my common difference. Plug back in to get a sub 1. I would do the one with smaller numbers for sure. So negative 40 equals a sub 1 plus 16 times the negative 3. Okay, so that's going to be negative 40 equals a sub 1 minus, because 16 times negative 3 is negative 48. So then I add 48 to move it to this side. So a sub 1 is 8. Now I know my starting number is 8. And then I would not do the pattern because it takes a little time. I would just go ahead and do the difference is negative 3. 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 is negative 1. Negative 1 minus 3 is negative 4, and that is the first 5. This time I'll make sure the commas kind of hit more of the box. There's your first 5. And then we move to example 5. Find the 10th term, so a sub 10, of an arithmetic sequence in which the first term is, so a sub 1 is 3x plus 2y, and the 6th term, so a sub 6, is 8x plus 12y. So you can see that the big difference here is that this isn't simple, just straight up numbers. It's more of an equation thing. Not really equation. You get the idea. There are complex parts here. You've got x's and y's and so forth. Multiple elements. That is a more precise way to say that. Okay, so if I am following, all right, so ultimately I need a sub 1 plus 10 minus 1 is 9d. So I need to work with these to find the a sub 1 and the d just like we did before. So we're going to have, and give myself a little space here. So a sub 1, oh, actually I can fill that in. A sub 10 equals 3x plus 2y plus 9d's. Ultimately, that's what I want to be solving for. Okay, so now in this formula, a sub 6, so we're going to have 8x. Oh, goodness, I left my plus off, didn't I? I did. Okay, plus 12y equals a sub 1, 3x plus 2y plus, and because it was a sub 6, 6 minus 1 is 5 times the common differences. And so the common difference is going to have an x and a y in it just like the other parts have had, because I can't get rid of them. I'm going to have multiples. But I do want to put my x terms together and my y terms together. So I'm solving for the d, so these are moving away. Minus 3x minus 2y equals 5d. And then every part has to divide by 5 in order to get it to d alone. So this becomes x, 5 over 5 cancels off. 10 divided by 5 is 2y. So here is my common difference. So now I can plug that in up here. We're ultimately solving for a sub d equals, we have our 3x plus 2y plus 9 times, and our common difference is x plus 2y. All right. I can't do anything at the moment with this 2y, but I am, or this whole term, I am now going to, to distribute. 9 times x is 9x. 9 times 2, 18y. Come over here because I'm out of space. So 3x plus 9x like terms, 12x. 2y and 18y like terms, 20y. And that is everything put together. So that should be my 10th term. And I've solved for everything they asked for in that lesson.